Welcome to PowerShell Wednesdays. Your big friend in the PDQ Discord. We talk about PowerShell quite a bit. In fact, you are the developer of a video game in PowerShell. What game is that? Could you tell us just a little bit? Because it's worth a plug. It's pretty sweet.
Yeah, so the game is called Eldoria, and I've since found out that there's another game called Eldoria. So, whoops. But fortunately, I'm not monetizing it, so I think we're good. But yeah, so it's a strictly text-based game written in PowerShell that's developed pretty well. It's pretty complex given what it's capable of doing, and recently it just introduced 6L graphics into it. So now there's going to be nice little graphics and pictures, like actual pictures in the terminal that you can use using 6L protocol. So
I got a little teaser of that.
Yeah, big shout out to Track D for that one. I was playing around with it and put a screenshot in the Discord, and he reached out to me, and we worked out a small little kink with how I was using it. And yeah, so now we've got images in Eldoria. So I am probably about 90% complete with the game. I'm hoping to release it before the end of the year.
Sweet. Yeah, I'm looking forward to that. Definitely keep tuned on the developments in that world. But today, my friends, and I'm going to click to the solo cam real quick. Welcome to PowerShell Wednesdays, your weekly PowerShell meetup, the only one that meets every single Wednesday. Had some internet problems, kind of ran around town, but I ended up coming back home because internet came back up. And you have some ideas of what you want to hear talked about at PowerShell Wednesday, let me know. We're also looking for new speakers. So if you have something you'd like to share, please reach out. If you're nervous first timer, I'm happy to go along through it with you, be a pair streamer with you, make it a little bit easier. But feel free to reach out and check out the PowerShell podcast every single Monday. We got you covered. Mondays, Wednesdays, everything in between. But today, Greg Martin, aka Not Gary, if you're familiar with his Discord handle, which doesn't confuse me 10 times a day. He is here to talk about Git, source control, and more for the PowerShell scripter. So, Gary, go ahead and take it away, my friend.
Or now Andrew the third.
Changing it again.
Yeah. So this is first of all, I put this together in like 2 minutes. So if this is going to be interesting. So I figured, like I said, we'll talk about the basics of source control, specifically around Git, but some of the concepts in Git are ubiquitous to other source control management tools like Mercurial or Subversion or anything else of that sort. But Git's kind of the one that everybody defaults to. So we'll just go with that one. And I got a little slideshow here to kind of start us off. As like a brief overview, like I said, we're going to go over some Git goals, what Git attempts to do, what you can do with Git, and learning some concepts in Git. We'll walk through installing it on Windows. I won't be torturing everybody with Linux today. Go through some initial configuration for Git after it's installed, which is really simple. And then we'll go over some local repository workflows, and then how things get ever so slightly complicated when you start talking about remote repositories.
Awesome. And this is intended for beginners. So if you are a beginner, feel free to follow along. By the end of it, you'll be in a much better space to actually start taking advantage of source control.
Yeah.
It's yours from here. Screen is shared. You're golden.
Cool. So really quick, get this out of the way, because I know some people are familiar with me. Some people aren't. We'll just get this out of the way. I am by day a senior Linux engineer at Progressive Insurance. I am an AI and automation specialist there as well. I LARP as a programmer, got about 20 years of experience with that. A beer engineer. I do enjoy good beer. And rumor is I'm a husband and dad as well. But that's just a rumor. So we'll go from there. Goals of Git. So this is kind of what Git aims to do, specifically when you're talking about version control. And like I said, these are more specific to version control at large, not specific to Git. But version control, the whole point is you track changes to source code over time. And that change tracking allows you to do things like version your final product, or roll back changes if, say, like you develop a feature, it turns out that you've got a regression and you need to roll back. Get a version control and Git specifically allow you to do some of those things. Git is a distributed version control system, so the repositories can be literally anywhere. You can have a full copy on your system. You can have a copy on your neighbor's computer. There could be a copy of it living up in GitHub or whatever other hosted solution you have. The point being is that the repositories are in multiple places rather than centralized, which seems kind of counterintuitive given what GitHub is, but that's the idea with the distributed repositories. Kind of in the same vein of that is collaboration. So because the repositories are distributed, it makes collaborative work on that source code, on the very same source code, a lot easier. So you can work it, like I can check out a repository, work on it on my computer. Andrew can have a same copy of the repository on his machine, work on that at the same time. And then, somebody else can have the same copy of it. And all three of us are working on the same source code at the same time. And then we can merge those changes and work together to resolve any conflicts that come along with that. So the kind of some basic Git concepts. Everything kind of revolves around a repository, right? This is where your source code lives at, and specifically with like game projects or anything else that sort, you'll have your graphics assets, your audio assets, so on and so forth. Everything can be put in repository. So basically any file. The repository is identified by the directory .git. That's where the repository itself is at, the change history, the internal state of Git, and so on and so forth. So when you make a Git repo in a directory, that .git directory is going to be placed there. Staging is a concept where you take files, and it's literally what it sounds like. You take files and stage them before you actually commit them to the repository. So you can have files that are staged that are ready for commit. You can still make changes to them while they're staged or pull them back out and do things with them. That's a little bit more of an advanced workflow, but generally the idea is that you're always going to be staging files first before you commit them into the repository. Branches, this is a core concept in Git. It's basically the same copy of the source code, just isolated from itself. Branches, you're always going to get a main or a master one. I forget which one it's called now. There's a new default. I think it's master. I could have that backwards though, but there's always like a main or master branch. And then you can work off of separate branches that will not affect what's in main, right? So any work that you do in a specific branch that's, not main or whatever, it's isolated from any other branches or whatever. So, like I said, the best way to think about it is just like an isolated pocket of like your working code. And branches can be either local or remote. So you can have local branches on your system that are different from branches that, say, like Andrew would have on his system, or branches that are different from what's up in GitHub. And then you can work with those locally, either push them up to the remote or push them elsewhere. And kind of feeding off of that is the concept of merging. So it's the idea of, like I said, merging just two branches together. So I have my branch, Andrew has his branch. We're working on code simultaneously, and then we want to merge those changes to make one final product. And that's where that comes from. Merging can get a little complex, especially when it comes to conflict resolution. And there's also some religion and philosophy around some deeper concepts around merging. But to keep it simple, we'll just say that we're merging two branches together. So we're going to jump out of the slideshow really quick, and we're going to install Git. So hopefully this, the live demo stuff is always good. So I've already downloaded Git for Windows. There's a specific website you can go to download it, and it's shown on the screen here, gitscm.com. You'll download the binary and go ahead and run it. I'm going to move this over here so I can see it. We're going to go ahead and accept the license, keep the installation location to its default, C program files Git. I usually take off the Windows Explorer integration, mostly because I don't like my context menus all muddied up. But so you can have your choice here. It's whatever. And then the only other thing I check is for daily updates for Git. This isn't as bothersome as it might seem. Git doesn't update that frequently. keep the default start folder location. For this choice here, the default editor used by Git, this has more to do with a certain aspect of your workflow. So if you try to make a commit and don't provide a message when you make the commit, Git will try to drop you into a default editor where you type the message out. By default, it wants to go to Vim. Vim, in my personal opinion, is the best editor ever, but we won't go into that one. So we'll just select Visual Studio Code as that, and we won't even have to see this ever again. For the initial branch name, again, this is the main master type thing. I just saw on the screen here that main is the new one. So you always want to let Git decide what this is, just for sanity's sake. For this option, leave Git from the command line in. Third-party software is the easiest one and doesn't muck up some other tools in your system. I always use bundled SSH. There's no real consequence from using either one. For the HTTPS, I always use native secure channel for this one. With the line ending conversions, again, default here, check out Windows style and then commit with Unix style endings. This is the better option to use if you have developers that are working on not Windows machines, so working on Mac or working on Linux machines. This is the one you want to do because the line endings do matter for the files, and it will cause issues if you try to move code back and forth between them. For this one, use the default min TTY. That you rarely have to use this, so it doesn't matter. The default pull behavior, I always leave this at fast forward or merge. We'll get into this very, very briefly near the end of it, but we'll just leave this at default. I do not use the Git credential manager. That's just a personal preference. So if you want to use it, fine. But for the sake of this tutorial and what I do, we're not going to use it. For the file system caching, do leave this one on. It does add a bit of a performance increase, even for small repositories. It's okay to leave it there. So go ahead and click install.
The fun part right here.
Yeah, watching paint dry.
This is on a VM, right?
Yeah, nice old souped up VM with 2 gigs of RAM. So
perfect.
I probably should have gave it a little more, but whatever.
Now you'll make people feel grateful for the computers that they have instead of complaining.
I was surprised. This is on my Hyper-V hypervisor, so it's been pretty stable, surprisingly.
Nice. I think you're on a VM, so you can do the bare metal setup. If someone doesn't have anything whatsoever configured, this is what you can expect to see.
Yeah. Well, that was the goal because my workstation, I have a tremendous amount of customizations to this, so it just wouldn't be of any benefit. We don't want to view the release notes because nobody really cares. Click finish. And at that point, you should have a working Git installation. So we can check that by opening a PowerShell window. Actually, I may need to open a new one. And because this is Windows Server, Windows Terminal doesn't work right. So make that a little bigger. Oh yeah, which isn't on there. Okay, Git works. So this proves that Git is in path and that we can use it. So once we have Git installed, there's some modest configuration we need to do first. And that is basically telling Git a little bit about yourself. Now you can do this, and there's one way to do this, but there's 2 scopes for doing it. So you can tell Git about yourself in a global sense, which means that these settings apply system-wide. Or you can do it on a per repository basis, which is a little bit more convoluted and cumbersome and just not really worth it. And especially if you're, single user machine, there's no real reason not to do it globally. So if we go back to the slideshow, give you an example of what this looks like. I'll do it over here as well. But so you would use git config. And the global means that you're going to set it across the entire system, not just, per repository. User.name is your actual given name, or in this case, my alias. And then you also give it your email address. So at a minimum, this is all we need to do to get started. And in this case, I'll use my actual name. There's no. There we go. Plain and simple. So once we've done that, we can really start using Git at this point. So with the local repository workflow, the idea is that you will make a directory where your project's going to live at. This is sometimes called project root. There's other in-house names for it that other developers will use, but essentially you just make a directory where everything's going to live at. You make that directory, and then you create the repository in that directory by using git init. And that's just going to set up the .git folder and all that other stuff to get it going. Once that's done, you do work as you would normally do. You make files, make changes, put things in there or whatnot. And then you move to the staging and committing process, where you will stage files. So Git becomes, Git can be aware of them, but they can't be staged. You'll stage them when they're ready to commit, and then you'll go ahead and actually commit the changes to the repository. And this is really all your local workflow is for 98% of the case, right? So we'll make a directory. And so this is our fun project. So we'll initialize Git. And you can see here that, there we go. So you can see here that the Git directory is actually created now after the git init command. I'm not going to dive too much into the contents of the Git directory, because that's where things start to get a little muddy. Especially when you want to start looking at like how Git works. But if you want to dive into that, there's tutorials on the internet, or I can talk in a private session with like a one-on-one with somebody if they want to go into the contents on that. But essentially this proves that your Git repository is ready to go. So like I said, at this point we can start working. So we'll make a simple file here. And it doesn't have to be source code. It doesn't have to be whatever. It can literally be any kind of file you want. And we're going to edit this. And we'll just say, so we'll write that to the file. Now, if we check the Git status, you can see here that we have an untracked. Git knows that there's a file in this directory, but it's not tracked, right? So we want to go ahead and track this file with the git add command. Now, we can type in the name of the file here just to track this specific file, which would stage it, or we can track everything that's not currently staged by using the dot. And then if we check git status, we can see that we have staged sample.txt, right? So this still isn't committed to the repository. It is staged. It's ready to be committed. So if we're good with all these changes and we want to go ahead and push this into a repository, we would do git commit, and then type with the M argument, which gives it some type of message. I'll say first commit. And we can see here that the result was Git went ahead and committed that staged file into the repository. So if we go to git status, we can see that there's nothing staged at this point because we already committed this file. Now we can see sort of like the recent history of the repository with git log. And that will show you a summary of all the commits. And you can see that there's our first one. So the commit message is displayed here. This is the hash of the commit. It's not really important that you know that for this particular point in time, but it does prove that we have something in the repository and it's there. And this for solo development, for everything trivial. This is enough to do whatever you need it to do, right? There's nothing more complicated than this. It does beg the question, though, about branches. So when we're talking about branches, for example, branches are a core concept for Git, like as I mentioned before. So the purpose of it is to, like I said, work on source code in sort of an isolated context away from other branches in the same repository, or specifically other branches that other people might have going on their systems. The crucial point of it is the crucial point I want to drive home with that is that for everything that's non-trivial, you kind of want to get in the habit of working in a branch, even for local private repositories. If you're doing something just to mess around, who cares, right? The point being is you want to get used to the idea that your main branch is kind of like the golden master, if you want to think of it that way. And everything that goes into main should be pretty heavily scrutinized, whereas everything that's in a branch is all disposable code to a certain extent. So you always want to work in a branch and then keep everything in main separately. So we can check our branches with the git branch command and see that we have just one branch right now, which is master. We can, let's say I want to make a new branch and make a new file in that branch, right? So we'll go, there's a couple ways you can make a new branch. There's the git branch command with a name, or you can use the git checkout command. Like that, which will make the branch and check it out. So we've introduced a couple concepts here. There's the concept of checking out a branch. So you can make a new branch, but not have it checked out, right? And the currently checked out branch is the one that has the asterisk next to it and is highlighted in green. Other branches that are not currently checked out will be in the same color, like just plain text color. So if you were to make a branch with just the branch operation, you can see that it makes another branch, but it doesn't actually check it out for you. Okay, so this command kind of consolidates them all in one. This is the more common workflow that I use, and that most other people that I know use Git do this, because it's not really useful to make a branch and not check it out. So especially because the code's not going to be operable at that point. So this is the more common approach, is to use the git checkout with the B option and then the branch name.
Will checkout create a branch if it doesn't exist?
I believe so. Let's check it. So I've never tried that before. Okay, so it won't. So with checkout, it looks like the branch does have to exist. I've just never thought about that before. So, but yeah, it looks like it doesn't actually work. Yeah.
What if you use -B? Stephen Judd says it might work.
Well, if you use the -B, right, that will make the branch if it doesn't already exist, which is the one that we did back up here, right? So if you do, I can type today. Right, so now that we use the B option, if that branch doesn't already exist, it will go ahead and make it. Again, the difference being that if you make the branch this way, it doesn't actually check it out. It just makes the branch, and you're still checked out on the branch you were before, right? So you'll have to actually do checkout manually to the branch you just made. If you do checkout B, if that branch doesn't exist, it makes it and then checks out that branch after it makes it for you.
Nice.
Yeah. So we're on a branch here. It's isolated. We're on a branch that's not master. So let's go ahead and make a new file in here. We'll do. Okay. And by dint of having made that file, we've already kind of deviated from where master is at, or main in some cases. So we'll go ahead and just put something in this file too. And again, kind of the same as before, we have files that are not tracked in this branch. So we are, we do need to make Git track this file specifically. We can see that we have now staged the file for this branch. Now, if we go ahead and commit this into there, so we've taken the staged file, committed it to the repository, and we can see that in this particular branch, we have the core commit from the upstream branch that we branched off of. And then we have the commit that we just put in there that contains another sample text file, right? Now, if we go back to master, so you can see that we're on master. We've checked out master. It is currently the one that we're on. Let's see here. And okay, well, that file we just made in the other branch is gone. And that's because those changes, those files and everything, those belong to that separate branch. Those changes have not been merged into master. So master is, again, branches are kind of their own like parallel universes of the same source code. We've got, the fun branch is going to have the sample text and the other file that we added to it, but master doesn't have that stuff. And now the file's been restored. And it's not really right to think of it as a file restoration operation. Again, it's more correct to think of it as, really, I know it sounds kind of silly to think of it this way, but it is kind of like a parallel universe of the same code, right? I mean, it's that you do have the sample text that you got from branching off of master, but you've also added stuff into this branch that differs from master itself. So that's what it's not really a file restore. It's you are dealing with a separate, but not the same code base.
Can you check out more than one branch at a time?
Not that I'm aware of. And it's not really clear what that would be useful for specifically.
Yeah, because when you're writing code,
I can't even think about
you kind of want it to be constrained.
I can't even think about why that would be useful. I'm pretty sure you can't. There's just no real, I can't think of a reason why you would want to have multiple branches open at the same time. You could, you could have, multiple repositories open, different, VS Code or editor windows or what the heck ever. But yeah, there's just no real value from having multiple branches open at the same time. I have heard of some custom version control systems that do things like that. But I've never used them and never seen them used, and Git, as far as I know, is not capable of doing that. So we've done this work in the fun branch. We've had fun working in fun, and we want to go ahead and pull this stuff back into master. We've had code reviews. We've had 25 developers sign off on it. This is the greatest thing ever. It's going to, make us millions and millions of dollars. So we want to go ahead and move this into our main or master branch so that we can, use pipelines to compile this stuff or whatever. But the point being is we want to merge it in. So what we want to do is we want to actually move to our master branch. So we're checked out in master, and now we can go ahead and merge fun in. So what we see here is a summary of the merge operation. We see that it is using the fast forward technique for merging. This is the file or files or changes or what a summary of the changes that were moved in to the branch. So this, again, summary here, this is our initial commit. This is the merge. And then if we look at the file structure, we see that, now we have that content in there. So we are checked out on master, and the content from the fun branch has been merged into main or master. It is main. Yeah, whoever said that was right. It is main, but for some reason mine set up as master, so it's whatever. This is about it for local repositories. It's the idea being that you kind of want to always work off of a different branch in main, do all of your work there. And this is something even I do on my own personal repositories. I always work off of a separate branch from master or main, do all my work there, test it in there, and then once it's ready to go ahead and merge it back into master. Master is kind of like the golden master for all of the source code itself, like the product that the program is trying to be. So there's also the last thing with branching, though, and this is probably one of the more fun things, is the collaborative side of branching, which is using remotes. So the concept of a remote branch is simply it's a branch that doesn't live on your computer, right? It lives somewhere else. Commonly, they live up in GitHub or GitLab, whichever one you want to use, or whatever else you're doing there. But it's essentially a branch that doesn't live on your machine. And to kind of illustrate this, I set up a dummy GitHub account where we'll go ahead and make a dummy repository. We will add it as a remote to the repository we just made, and we'll push the code up to GitHub. So when you have no repositories here, it kind of displays a little bit different, but we can click the green Create Repository button. We'll name the repository something terrible. We can leave all these default. Public repository. I don't need a README. We don't need a git ignore, or we don't need a license or anything else of that sort. Okay, so we have created a repository up in GitHub that can act as our remote. Now, there's a couple of ways to communicate with GitHub. You can use what are called personal access tokens, or PATs, or you can use SSH keys to communicate. I have a strong preference for SSH keys, although personal access tokens are also really viable as well. They kind of your pick. But what I will illustrate is doing a SSH setup for this, since it's probably one of the more common workflows. Personal access tokens can work as well, but most people, that myself included, that I know that use this, will do it with SSH keys. So the first thing we're going to do is we're going to make an SSH key for ourselves. And this is disposable, so who cares? So back in our terminal, we'll do SSH keygen. And what this is basically is it's going to make a SSH keygen with a key type of ED25519, which is kind of, we could actually omit this if we wanted to, because I think it defaults to it. So the SSH keygen tool comes with Windows now. It used to have exclusive rights on Linux, but it is part of Windows. So we're going to be prompted, do we want to make an SSH key? Yes. Where do we want to save it at? The default location is .sh. You can put in a passphrase if you want. For this particular example, just to make things simple, we're not going to make a passphrase. And now we have our key generated. So we're going to want to open the public key file. And this is what the public key looks like for that. So we want to get the public key contents, essentially, and copy them up to GitHub. If my mouse will go over there. Woohoo! And then once we're back in GitHub, we will go to settings. This is your account settings, not the repository settings, by the way. And then there's a section specifically for SSH and GPG keys. We'll go ahead and add the SSH key. You can name it whatever you want here. This doesn't matter. And it is an authentication key. It's not a signing key. Paste the contents of the key into there. Oh. You're going to fight me, aren't you? There we go. Okay. So we paste the contents of the public key into the SSH key text area. Click Add SSH key. And of course, I'm going to be prompted for a password. And now we've added our SSH key. So Git knows about your particular SSH key. And at that point, we can interact with any repository on our account using SSH as a communication protocol. So if we go back to the repository, something terrible, we can select SSH over here. And then because we have an existing repository that we already set up, we can go ahead and follow the steps down here to add the remote to our repository. And this is a fairly simple process. Basically, we can copy and paste, or we'll just step through it real quick. So the first thing is we're going to add the remote to our repository, naming it origin. So essentially what this does is git remote is used to manage remote branches. We're going to add a new remote branch named origin. And this is common for GitHub. GitHub has a strong preference for naming all of its remotes origin. And this is the URL to access that remote using SSH. We can see what remotes that we have by just typing git remote. This is not really useful sometimes because it just says the name of the remote or enumerates all of the remotes that you have listed. If you want to see the URLs, which sometimes is valuable, you do git remote tac v, and that will actually show you what the URLs are for each remote that you have managed with this repository. So keeping with what GitHub's telling us to do here, we'll go ahead and run this command this will set us up on main for the main branch. So what that does essentially is renames. So like if it's, if your main branch is, the core branch is master, like ours was previously, this renames it to main and moves everything like the commit history over to that new branch. And then finally, what we're going to want to do is we're going to push. So when you're talking about remote branches, the concept of pull and push comes into play. So if you want to send your branch changes to the remote, you're going to push them to the remote. If you want to synchronize your local branch with the remote one, you pull. And that's the basic terminology there. You push up to commit the changes, you pull down to get fresh ones. So we'll run git push. This is prompting us for our SSH key that we created earlier. And because it's SSH, it's key-based authentication. So unless we set a passphrase, it's not going to prompt you for anything. This is just this is confirming that we've pushed all of the changes up to the remote. So if we come back to our remote repository and check something, you can see that we've got our repository now created up in GitHub. And the files are intact.
Quick question.
Yeah.
Does PowerShell remember the SSH key, or do you have to enter it every time?
So that is something that's agnostic to PowerShell. When you're using what makes SSH really nice is that like the SSH itself is a key-based authentication mechanism. So once you have made a public-private key pair and you tell GitHub about your public key, you will only be prompted once to make sure that you're using the right key at this point. And if you are using the right key, you press enter to continue, and then your SSH remembers that you've authenticated with this host using this specific key. So unless your key changes, or unless GitHub decides that they want to change something on their end that affects how the key works fundamentally, then you should never be prompted for a passphrase. Unless, like I said before, unless you've set a passphrase for your SSH key. Some places do that. I know some developers that do that as well. But if you haven't set a passphrase, once the key is remembered by SSH, you'll never be prompted for it. And that's really all there is to basic Git operations is understanding, the core concept of branching, your branching and staging. Your files are staged, then they're committed, which you have to do. And then with branches, you can have local branches and remote branches. And that allows you to collaborate. Most remote branching occurs on GitHub, but you can have a remote anywhere. I have my own private GitLab server that I run, so that's a remote for some of my repositories. But it could really be anything as long as it's a source for Git communication or SSH communication.
Awesome. I do have a question and a request, if I could.
Yeah.
Could you export your slides and then show us how to commit those? People are mentioning VS Code. If you're familiar with the integrated stuff in VS Code.
Yeah, I can showcase VS Code really quick. That I was holding off on doing that mostly because VS Code you can do pretty much all of this stuff in VS Code. There's some things in VS Code that you can't do, like setting up the repository, for example. Well, at least setting up the local repository. It interacts with GitHub pretty well. But since we already have a remote up there on GitHub, this will make this really simple. So we'll open VS Code if my VM wants to behave. There we go. So on the welcome screen, let's see here. We'll open up the Git. Oh, let me reopen VS Code because I have Git installed. Let's try that again. Hey, there we go. Okay, so we can go to the Git, the source control pane, and you see that we have nothing over here, right? But we can open a folder, so we can open a local repository that we have, which in this case we'll do, or we can close the repository already from GitHub. But since we already have one local, we can just go ahead and open it. That would be, let's see. Users, administrator, and it's this folder here. Now, VS Code will recognize this as a repository so long as it has that .git folder in there and there's stuff correctly associated into it. If it's like a corrupted .git folder, it may not recognize it correctly. We're going to go ahead and trust the authors here because I trust myself sometimes. And like you see here, this all the files that we created before by the command line. These are all available already because in the file explorer.
Can you zoom in a little bit? Control
yeah,
plus
sure.
or whatever.
There we go. How's that?
Looks good.
Awesome. So with the source control pane, there's a graphical explorer for your commit history. You can see that much like we were seeing with git log, this is the same content that we would see with that. It's just displayed visually and a little bit cleaner. So you can see specifics about the commit if you hover your mouse over it. You can see that I committed that 24 minutes ago, the commit message, and specifically what branches this file is in and so on and so forth. Gives you links to open things on GitHub. And these are more specific to the branch hashes themselves. We can check out which branches we have available to us by clicking down here. And the command palette will open up and we can see that we have a couple options. We can make new branches, which would be fresh ones, create branches from an existing branch. We can also see what branches we have available and whether or not they're local or remote. So these ones right here would be local branches that we have. And on the bottom here are remote branches. You can see the prefix with the remote name called origin. And it specifically says remote branch on the side. So let's do a little bit of work in here. We'll check out and we'll make a new branch. We'll call it We'll call it Plakira. And so immediately you can see here, like, hey, we noticed that this branch is not in the remote. So it gives you the option to publish the branch to your remote. And we'll go ahead and do that. And you don't have to do that at this particular point. You could just go ahead and, do whatever work you need to do and then commit and push afterwards. But we'll just to make it simple, we'll do that. VS Code will sometimes prompt you if you want to periodically run git fetch, which is functionally the same thing as a pull, but we're not going to go into that too much. We'll just ignore that for right now. So we'll make a new file. And we'll just start my sweet typing skills. So we save the file and we have a notification here that, oh, there's some changes in your repository. So, and these changes, it doesn't really matter too much from VS Code's perspective, like the difference between staged, more specifically tracked or staged, like it does on the terminal. Like it doesn't really matter that much here. It's just going to show you, what changes you have in the repository or what it's noticed is different. So we have that one file here. We've changed stuff. We're going to go ahead and make a commit message. And some people do get pretty religious about what should be in a commit message. I frankly don't really care because I don't pay attention to it that much. But so we're just going to make a garbage commit message. Now, what we can do here is we can either commit local, which isn't going to do anything to the remote, or we can do a commit and push, which is going to commit local, and then it's going to go ahead and push it up to the remote, we're going to go do that in this case. So there's no stage changes. Do you want to stage them all commit? Yes. It committed, it's doing the push. Now you can see that our graph updated down here. So you can see that the commit was made to the local repository. And now it is pushed. So if we go back to GitHub, oh, hey, there's a new branch. Plakira has recent pushes 9 seconds ago. So if we click on that, we're now viewing the repository from the perspective of the Plakira branch, which shows that, hey, it's one commit ahead of main. And this identifies specifically what's different between main and the branch, than the Plakira branch. Now you can do your branch merging inside GitHub. You can do branch merging inside VS Code. If you're working in a more structured environment, you'll do pull requests, which will, I'm not going to demonstrate here just for the sake of simplicity, but usually what happens in more structured environments is your main branch is marked as protected. So you can't actually commit to it or anything, at least directly. So anything that comes into main is always going to come from a pull request. And once that pull request goes through, review and so on, you can merge it into main from GitHub.
Yeah, that's a good call out. Many projects that if you end up contributing code, they'll have that set up. So very important that when you clone it, you create a new branch.
Yeah. Yeah. Like I said before, you always work. You got to get in the habit of working in a separate branch. If you're doing something like just trying out Git or trying out source code or whatever, who cares? But the second you start working on a program that's doing something productive or matters or as part of your job or something to that effect, that main branch is always going to be protected. So you're always going to be forced to work in a branch and go through pull requests and all that kind of stuff.
What is the difference between push and sync?
So this is another one of those things that I don't. One of those.
I'm pretty sure sync is just it pulls also.
Yeah, but it has more to. I think it has more to do with merging, right? So when you do a pull, it will pull the changes down, and actually, like merge them into the branch that you have. I don't remember specifically what sync does. I don't use it that often. My workflows are usually constrained to push and pull. So I'd have to do a little bit of research on it. Git's one of those tools where like there's all these bizarre differences between functions that do the same thing, like pull and sync or merge or rebase, which is the other like big religious conversation. I think actually Gilbert and I were having some idle banter about that on LinkedIn the other day. But again, they both do the same thing, and there's just minor differences in how they accomplish things. And 90% of people that use Git won't ever care about those differences.
Yep. Yeah, you don't need to know everything to be able to take advantage of Git and source control. Yeah. I do see someone well-trusted says, sync is just push and pull. It helps make sure you don't have conflicts.
So, there you go. Okay.
Another question. This one's a little bit harder because I've never even heard of this. Maybe you have. Could you describe Git sparse checkout, and why would I do that versus a regular checkout?
Oh, that's a good one. I actually don't know the answer to that one off the top of my head. I've never done a sparse checkout before. And I've heard of it, but I can't remember specifically what the motivating factor is for using a sparse checkout. I'd have to ask around for that one.
Some advanced use cases. Hopefully, if you're in a position where you have to do a sparse checkout, there's some senior dev who, explains to you why.
Yeah, I know that's anticlimactic, but again, it's one of those things where, there's just never really been a need for it. Yeah. Checkouts work just fine for virtually everything that you do in Git.
Yep. And I will say pretty much everything you showed is what you're going to normally run into. But whenever I've run into like weird stuff where I have to undo something that I mucked up, there's a website called ohshitgit or dangitgit.com that can help you traverse those confusing scenarios.
You touched on something there too, which is, one thing we didn't cover in this is like reverting changes specifically. The reason we didn't go into that is because that's kind of another swamp in and of itself. There's some simple tools around reverting changes for, things that have been staged versus things that have been committed versus things that were blasted out to your remote. There's ways of undoing changes for each of those, but the water gets super muddy whenever you start talking about, the latter two portions of that, which is like, I made a change, blasted it to remote, like, oh shit, I shouldn't have done that. Then there's a whole process of backing that out, and it gets really ugly really fast. So, I mean, we could probably do another 30, 40 minutes on those kinds of topics. But again, and I hate to sound like I'm kicking the can down the road a bit, but realistically, I mean, I've been using Git for probably 17 years, and it doesn't really get much more complicated than this, even in a professional environment. Most engineers just need to push, pull, and then commit. And, if there's a merge conflict, you do it manually we do it manually through GitHub. But, we really haven't encountered too many fringe cases.
Yeah. You want to be in the spot where you have the files to then do things with, rather than waiting till you have every single edge case, mapped out in your mind. Just create your repo or clone one if there's a project you're using, and start dabbling. Yeah.
You don't need to know the Git handbook back and forth. In fact, I would probably discourage people from reading that back, front to back. That's very, very dry reading, and, not to muddy things too much, but, Git is not the only player in town. It's just the one that's most prolific. Some of the idioms that are in Git aren't expressed into the version controls, and companies do use things other than Git. It's not the only player in town. But which is why I say, just figure out what you need to do to be proficient with it as much as you need to. And then if you start, tripping on your shoelaces for edge cases, and figure that out when it happens.
Yep. Ask for help too. There's a lot of experienced people who've probably been there before. It can save you some time.
Yeah.
Awesome. Could you make the slides available as well?
People absolutely. Asking. Yeah, absolutely.
So I guess people just need to get started, get your repos set up. I think a lot of people in the PowerShell world, they'll create their first repo, probably make it private because they're a little shy. That's okay. I was there too. Maybe call it PowerShell scripts or, something like that. let it be your catch-all. But as you get to the point where you're writing more tools, you can create your own repo for a module that you're making, or for a certain set of scripts that address a problem at work. And if you don't already have source control being used by others, you can make some headway in that department and set yourself up for success, because when spaghetti hits the fan, trust me, you are going to be so grateful that you either get set up, or so regretful that you didn't. And you have your little 2-folder system with your .olds and all that kind of thing. You'll feel like a pro. Just use Git.
2 folders.
2 folders, yeah. That's a reference. That is a real reference. Awesome, man. Well, thank you for your time. Thank you, everybody, for joining us. We're here every single Wednesday. We're learning new things. Check out the PowerShell pod to learn out how to build a career around PowerShell. Join us for PowerShell Wednesdays to see how to actually use the language and learn from great people like Andrew III, aka Greg Martin, aka Not Gary, aka the man who's really adopted Plakira. It's becoming nomenclature now. I don't even know if I used that right. Well, hey, thank you for joining us. People want to connect with you. Where can we find you on the internet?
I'm active on LinkedIn. Just my name, on Gregory F. Martin on LinkedIn. My blog is themartinmethod.com. And that's about it. I try to stay off the socials. So, but yeah, the blog and LinkedIn are most it. And obviously the PDQ Discord.
Yes. Awesome. Yeah. PowerShell scripting channel. We're always having fun there. Discord.gg/PDQ. We will see you all around. See you next week. Still looking for a speaker. Anybody reach out, and have a great rest of your day. And Dylan Carr, get rid of those 2 folders in the .olds. Get rid of them. We'll see you around.